All right, so let's check. Is this also, this is still 2.1. So this is 2.1, number 28.
Yeah.
We have four linear equations in two unknowns. Okay, so first, what the heck does that mean? Like, what's an equation in two unknowns? Can somebody give me any example of a linear equation in two unknowns?
X plus Y.
Good, close. X plus Y is an expression.
Equals Z.
Damn it. I was with you, Jordan.
Equals B.
Equals 1.
Some constant.
Yeah, equals some number. So Karen's equals 1 is fine. So this is an example, right? Jordan is so embarrassed he shut his camera off.
Nah,
Jordan-
it's just acting funky.
Oh, sure. It wasn't meant as a dig, buddy. All right, so yeah, this is some equation in two unknowns. Now, they say I've got four of these. So I'm going to put some scalars, right? So I'm going to say, okay, so I kind of thought about an equation in four unknowns. Now, in order to have four, I guess I'm going to have like ax plus by is c, and let's see, I guess dx plus ey is f, and now I'm going to run into the fact that I don't know the alphabet.
I was going to say, we're not doing English here, Joe.
What's that?
We're not doing English here. Like,
Good. Gx plus hy is I, and wx plus, oh shit, I don't want to skip to the end. I guess I should probably do the alphabet in order. Jx plus ky is L, give or take. Okay, so here's my four equations in two unknowns. And the row picture shows 4O. So if there were numbers for all these things, what would these four things be? Like, what's x plus y equals 1? What is that?
a line.
Good. That's a line. So it's four lines for the row picture, right? See my four lines? Okay, and then the column picture, so this is kind of the rows, right? The columns for this are x times some column plus y times some column equals another column. So what are the coefficients on x's here?
A, D, G, J.
Perfect. And then similar for y and similar for, so this one's C, F, I, L, or whatever. Right? So the column picture is in what dimensional space? Where does this column live?
Four.
Perfect. Yep, it's got four components, so it lives in four-dimensional space.
Okay.
And then the equations have no solution unless the vector on the right-hand side is a combination of... In other words, when does this thing work? Well, this thing's only going to work if you can pick an x and a y so that when you add these two columns together with those scalars, you get this thing, right?
Mm-hmm.
You guys see that? So it has to be a combination of the columns. Does that sort of make sense?
Yeah, I was mostly confused with the four-dimensional part.
Yeah. So this actually, believe it or not, is the kind of drive behind least squares regression. You guys know what least squares regression is?
No.
This is this thing where you have a whole bunch of dots. They look like this,
Oh, yeah. No, I remember. Yeah.
and then you try to throw you try to throw a line through here. You're like that one, right? Like that's the best fit. Like you all can do that with your brains, right? Human beings are pretty good at estimating best fit lines, actually. Um, but the question is like, how does the computer figure out the best fit line? And actually, what it kind of does is it sort of looks at data a little bit like this, and these points don't lie on a line. But if they did, then that result would be a linear combination of the rows. You guys see that? Or of the columns, rather. So what it does is it kind of finds the closest point in high dimensional space. Don't worry, we'll talk about this more later. But for right now, I just want you to know that's kind of what it's doing. So don't feel like this is completely irrelevant. We do circle back to this problem. Sort of follow?
Hmm. Now I'm wondering, like, what exactly are you doing with the linear equations when you set them up as a matrix? Because I'm a little confused at how four two-dimensional equations can come out to be a four-dimensional vector.
So if we're thinking about two-dimensional equations, right, we're thinking about rows.
Yeah.
And if we're thinking about four-dimensional space, we're thinking about the columns. Right? And so switching pictures there is weird. And that's totally okay for that to be weird. The other thing in this example that you're probably tripping over is that the in the row picture, the odds of this having a solution are really, really low, right? Like if I just assigned my, A through L at random, this ain't gonna work, right? Because there's only two variables and there's four equations. So odds are it's probably not gonna work. That's actually kind of this idea, right? If you have 4 points in space, the odds that they're on a line are really, really low. You guys see that? All right. Any other questions from 2.1 or 2.2 before I move on to showing you how to multiply matrices?
No.